The topic today is energy resources. Energy resources are classified into two, that is renewable energy resource and non-renewable energy resource. The energy resources which can be regenerated in a short span of time, it is all called as renewable energy resources, and it is all non-exhaustible. Always it is existing. Anytime it can be used for the production of electricity. And non-renewable energy resources are said to be exhaustible because such resources cannot be regenerated in a short span of time. The resources which come under non-renewable energy resources are fossils and nuclear fuels, which are available under the earth crust. Renewable energy resources examples are solar, wind, hydro, geothermal, tidal energy resources. Fossils and nuclear are considered to be non-renewable because on continuous usage of such resources for the production of electricity, at one point a huge consumption makes it exhaustible, and therefore the formation of the fossils or nuclear fuels once again under the earth, it takes a large time for the conversion. It is a slow process, and therefore it is all considered to be non-renewable energy resources. So, in this unit, under this topic, what is discussed is how well this renewable energy resources are used for the production of electricity. How well renewable energy resources and the non-renewable energy resource, particularly nuclear energy, is used for harnessing electricity. And coming for the nuclear energy, to understand the conversion, let us start with the nuclear reactions. So, nuclear reactions are those reactions where protons and neutrons take part in the reaction. That is the difference between the nuclear reaction and chemical reactions also. Usually in chemical reaction, the electron which is rotating outside the nucleus take part. Whereas in nuclear reaction, the protons and neutrons which is present inside the nucleus is taking part, and therefore, so these protons and neutrons, since it is taking part in the reaction, during the nuclear reaction, the atom is being converted into a different atom. That is, the element is being totally converted into a newer element. And coming for the types of as an example for a nuclear reaction, that is carbon 12, which is an element, radioactive element that reacts with hydrogen proton to form nitrogen 13(7), which is another radioactive element with the liberation of the gamma radiations. So this is a example for nuclear reaction. Any radioactive element with that of reaction with protons or helium, it gets converted into totally a new element with the liberation of radiations and plus huge amount of heat energy. So the huge amount or enormous amount of heat energy which is liberated during this nuclear reaction is responsible or utilized for the production of electricity. Nuclear reaction, as we said, in the nuclear reactions, protons and neutrons which is available inside the nucleus is taking part. So there are four types of nuclear reactions, which are nuclear fission reaction, fusion reaction, nuclear decay, and transmutation. And seeing the first process, that is fission reaction, it is all explained with the radioactive element, that is uranium 235 and 92. 230A5 is the mass number and 92 is the atomic number, which means 92 is the number of electrons, 235 is the number of electrons plus number of neutrons. So this radioactive element, when it is made to bombard with a subatomic particle, that is neutron, on bombarding, what happens, this gets converted into uranium 23692 plus, and it is all splitted, cleaved into two newer atoms, that is krypton and barium. Uranium 236 or 235 on bombarding with a neutron, it gets cleaved into two newer atoms, that is barium and krypton, with the mass number 144 and 89. So in addition, it liberates three other neutrons also. So these three other neutrons, again it goes and dashes with other uranium 235 elements, atoms, so which will be a continuous chain reaction. So when one uranium 235 atom is cleaved with the help of neutron, what happens, the amount of energy which is liberated is said to be 931 million electron volts. So this much amount of energy is being released when a single uranium atom is being cleaved by bombarding it with a neutron. So this amount of heat energy which is liberated can be utilized for the production of electricity. So that is how well the nuclear energy is used for electricity harnessing. The device which is used for producing electricity out of this fission reaction is said to be like nuclear reactor, and this is how a nuclear reactor looks like. This is how a nuclear reactor looks like. So this is said to be the core nuclear core, inside which it has got a pressure vessel. It is a nuclear core inside which it has a pressure vessel. So inside the pressure vessel are available the fuel rods, the three rods which is seen down. It is all fuel rods. It is all fuel rods, and above the fuel rods are placed the control rods. First, let me tell the components present inside the nuclear reactor. Then, separately, we'll discuss the function of each one. So here, this as a whole is a nuclear reactor core, inside which a pressure vessel is seen. Inside the pressure vessel, the fuel rods are placed. Above to the fuel rods, some control rods are placed with a piston-like connection. So this piston helps in moving in and moving out of the control rods. Whenever necessary, the control rods can be pushed inside, and whenever required, it can be moved out. From the pressure vessel runs a cooling system where water is being circulated. So water from ocean, it is all circulated into the pressure vessel. So when the fission process is going on, huge amount of heat energy is liberated, and the heat energy, when it is transferred to the water which is coming inside, sea water which is coming inside, it heats up the sea water. So on getting heated, on getting warm, or on getting hot, what happens to the seawater instance? It gets converted into the steam. So the steam is being used for it is all taken. It is all taken, and it is used for running the turbine which is placed here. The turbine, when the turbine is run with the help of a steam, then the power of steam is being converted into mechanical energy. So turbine in turn runs the generator helps in the conversion of mechanical energy into electrical power. So that is the simple working of a nuclear reactor. So the components are separately, let us see what components are placed inside the nuclear reactor. As we said, it has got fuel rods. So fuel rods are either it can be uranium 235 or plutonium 239. So uranium, as we said earlier, uranium on bombarding it with a neutron, it gives rise to it gets splitted into two different atoms, that is krypton and barium. Simultaneously it produces three neutrons. Again, this three neutrons plus energy it is released. Three neutrons, it go and attacks some other three uranium 235 atoms, and again more amount of heat energy is being liberated. So this amount of heat energy is used for the conversion of electrical energy. So the as fuel rod, what is placed is uranium 235, atom uranium 235 or plutonium 239. This is all placed as fuel rods. This is what is undergoing the fission process also. It is dashed with uranium neutron, and it is splitted into different atoms plus three other neutrons. In a controlled way, the reaction is carried out. For controlling the reaction, control rods are being placed, as we said showed in the picture. So down it has got fuel rods. Down it has got fuel rods, above which the control rods are placed. The function of the control rods, it is to stop the neutrons which are produced during the fission reaction. The three neutron which is produced in the nuclear reaction, at times it has to be controlled, it has to be absorbed, and the fission reaction should be stopped. So how to absorb the neutrons which are produced? by pushing the control rods down in between the fuel rods, the neutron which is produced during the fission reaction, it is all absorbed with the help of this control rods. So which acts as control rod? Elements like that of cadmium and boron, it is all used as the control rod, which means, so these cadmium and boron, it captures the neutron which is produced during the fission reaction. Thereby it stops the fission reaction and helps to control it. The neutron which are produced is absorbed by the cadmium and boron. That is how the chain reaction is carried out in a controlled manner. So other than the fuel rods and control rods, we have got something called moderator, which acts as the moderator in sense ordinary water, heavy water, graphite or beryllium can be used as moderator. The purpose of moderator in a nuclear reactor is to slow down the neutrons. Neutron which is moving in high speed, dashes with uranium-235 and vigorously it produces three other neutrons plus splitting of the nucleus. So when the speed of the neutron is huge, splitting also happens, fission also happens at a vigorous rate, and the amount of heat energy is huge. So therefore, to slow down the neutron, these substances like that of ordinary water, heavy water, graphite can be used. On using the moderators, first the slow neutron bombard with the moderators, so the speed of the neutron gets slowed down, and then after it is made to bombard with the uranium fuel rod like that of uranium-235. So by this way also the chain reaction can be taken in a controlled way. So that is the function of moderator. And next it is coolant. The purpose of coolant in any nuclear reactor is to reduce the heat energy, heat produced during the fission reaction. That is one purpose. And also it actually acts as a heat exchanger also. The heat energy which is produced during the fission reaction, it is all totally dispersed to the seawater which is circulated into the pressure vessel. The seawater acts as the heat exchanger. The heat which is produced during fission reaction is dispersed in the seawater, and therefore the water turns into the form of steam. So that is how the heat has been exchanged to water. From the reactor core, the heat energy is being dispersed to water, and water is being converted into steam. The power of steam is used for running the turbine. So as coolant, water can be used. As a heat exchanger also water is used. So that is how the heat energy which is produced in the fission has been turned into steam. Then it runs the turbine which is available in the nuclear reactor. When it runs the turbine, the heat energy is being converted into the mechanical energy. Mechanical energy, once again it has to be converted into electrical power, and that is done with the help of the generator. So generator converts mechanical energy from the turbine into electricity. So that is how a nuclear reactor works.